Okay, on to page 2 of the notes. So here at the top in the box, we have these properties of limits. I don't necessarily need you to have these memorized. I really just basically need you to know that these exist, and these properties are kind of working behind the scenes whenever we evaluate limits. Okay, so most of these are straightforward. They're not going to require a lot of thought, but it is important that you know that these limit laws, as they're called, exist, and that they're working behind the scenes whenever we want to find a limit. Okay, so we're going to start with example 1 and example 2 here, and we're going to just basically work some very straightforward limit problems. The very first thing you're always going to try whenever you evaluate a limit is just to plug in the x value that's given. So that the limit as x approaches 2 of 4x squared plus 3, you're just going to try to plug in the 2 for x. And so in this case, I'm going to get 4 times 2 squared plus 3. And if I evaluate that, then I'm going to get 4 times 4 plus 3, which of course is 16 plus 3. And so this limit, the answer to this problem, is equal to 19. Now sometimes when you plug in, you're going to get a nice answer like that, like 19, and you're going to be done. You don't have to do anything other than that. That's not going to happen a lot of the time, but in this particular case, it does. Okay, so example 2, we're going to try the same thing. We're going to first of all substitute, sorry, I don't want to write the limit anymore. I want to just go ahead and plug in. So let me erase that. And I want to try to plug in x equals to 1 into this function. So that's going to say 1 squared plus 1 plus 2 all over 1 plus 1. Which if I evaluate the numerator, 1 plus 1 is 2, plus 2 is 4, over 1 plus 1 is 2, and so the answer to this problem is 2. Okay, so you might be thinking, really, that's it? That doesn't seem really hard, and you're right, it's not. Unfortunately, we don't really see a ton of those super easy problems on the AP exam or in calculus in general, but not to worry, the rest of the problems are not real hard, so we'll work on those next. Okay, so what the above examples illustrate is that sometimes in order to compute a limit, all you really need to do is just directly substitute in what x is, and you're done. Okay, however, this does not usually work, and so we have a couple of techniques to help us using algebra to figure out what exactly a limit is. Okay, so the first technique we're going to talk about is the factoring out technique. Now, the first thing you're always going to try, just like we did on examples 1 and 2, is you're going to try to plug in what x is and see what happens. Okay, so in this case, this is the limit as x approaches -3. I'm going to plug -3 into this function. So -3 squared plus -3 minus 6 all over -3 plus 3. So if I evaluate that, -3 squared is 9, minus 3 is 6, minus 6 is 0 in the numerator, and in the denominator I'm also getting 0. Okay, so I get this curious thing, 0 divided by 0. So the question is this equal to 1? Is it equal to 0? Well, what exactly is it? Well, the answer to that is it's really not anything. So what I'm going to do is I'm going to put quotation marks around it, because this is what's called an indeterminate form. Okay, and what an indeterminate form is and what it means is that I don't really know the answer right now. Basically what an indeterminate form signifies is that I have to do some more work, I have to do some algebra in order to figure out what the answer is. And the algebra that we're going to do here is factoring. So what we're going to do is we're going to factor that numerator. Okay, so the original problem is going to equal the limit as x approaches -3. If I factor the numerator, I need factors of -6 that add to 1. So that would be x plus 3 and x minus 2. Now it's nice that it factors that way, because now what you should notice is that the x plus 3 and the x plus 3 are going to cancel. And so this problem is now equal to the limit as x approaches -3 of x minus 2. And now that I've made that simplification, what I'm going to try to do is plug in again. Okay, so if I plug in -3 for x, I'm going to get -3 minus 2, which is equal to -5. Okay, so there's your first technique, is factoring. So always try to factor if you get that indeterminate form. That might be a technique that you can use to answer the question. Okay, the second technique here is called the common denominator technique. So let me just illustrate what that is talking about. First of all, if I were to try to plug in x equals to 0 here, this term right here is going to go to 1 over 4. 1 over 4 minus 1 over 4, of course, is 0. And then in the denominator, it's just an x, so that's going to go to 0. And once again, I get this indeterminate form. Okay, so what I'm going to do in this case is I'm going to find a common denominator for those two fractions in the numerator. Okay, well, the common denominator is just going to be the product of those two denominators, which is x plus 4 and 4. So I'm going to make a fraction here. The denominator is going to be 4 and x plus 4. Okay, in order to get them to be the same denominator, this term is going to require a 4, and this term is going to require an x plus 4. So what I'm going to end up having in the numerator is 4 minus, because this was originally a minus sign that you can't really see now that I've covered it up with my pen, 4 minus x plus 4. And then remember, that was all divided by x. Okay, well, instead of dividing by x, I'm going to write that as times the reciprocal of x, which is just 1 over x. Okay, so now I'm finding the limit of this thing. And this is the limit as x approaches 0. Let me not forget to write that in there. Okay, if I clean this up and do some more algebra here, this is going to be the limit as x approaches 0. I'm going to go ahead and distribute this negative, so that's going to be 4 minus x minus 4 divided by 4 times x plus 4, and then don't forget the times 1 over x. Okay, from here I have some like terms to collect in that top left numerator up there. So this is going to be the limit as x approaches 0 of negative x divided by, I'm going to go ahead and move this x to be over here with this other stuff. So this is going to be 4x times x plus 4. Okay, hopefully now what you notice is that those x's are going to cancel out. So this x and this x are going to cancel. And what I'm going to be left with is negative 1 divided by 4 times x plus 4. Okay, now that I've made those simplifications, I'm going to try to plug in 0 again for x. And so when I do that, I'm not going to be dividing by 0 this time. I'm going to have negative 1 over 4 times 0 plus 4, which if I do the arithmetic is going to be negative 1 over 16. Okay, so this limit, this original limit up here, is equal to negative 1 over 16. Okay, if you have any questions about that, then please feel free to let me know. Okay, the last technique we're going to talk about is called the rationalizing technique, and you want to use the rationalizing technique pretty much whenever you see a square root going on in the problem. So I'm going to write that next to it up here. Whenever you see a square root is when you're going to want to use the rationalizing technique. Okay, and the way that we rationalize something is always by multiplying by the conjugate. So hopefully you remember from Algebra 2 and from pre-cal, the conjugate just means whatever the numerator is, but then the opposite sign in the middle. Okay, so again, the first thing we always want to try is to plug in 0 first. So if I plug in 0, that's going to say the square root of 0 plus 1, which is 1, minus 1 divided by 0, which again is going to give me this indeterminate form 0 over 0. Okay, so what that tells me is that I'm going to want to do some algebra to try to figure out the answer here. And the technique we're going to use here is the rationalizing technique because we see the square root. Okay, so I'm going to actually erase this so that I can multiply by that conjugate up here. Okay, and so the conjugate of that numerator is going to be square root of x plus 1 and then plus 1. Since this was a minus, I just changed the sign when I do the conjugate. And then this is going to be the square root of x plus 1 plus 1 in the denominator as well. The reason I have to multiply by it in the denominator is so that I make sure that I don't change the problem. Okay, so when I do this, I'm going to come this way. The limit as x approaches 0. When I multiply these numerators together, basically what happens is I only have to multiply the first terms and the last terms. And the reason for that is because what I'm multiplying together are conjugates. Okay, so if I multiply the first term, the square root of x plus 1 times the square root of x plus 1 is just x plus 1. And then if I multiply the second terms, negative 1 times positive 1 is a negative 1, all over x multiplied by that conjugate. So square root of x plus 1 and then plus 1. Okay, well now you should hopefully realize that those 1's in the numerator are going to cancel. So I'm going to get just x in the numerator divided by x multiplied by that conjugate that we multiplied by in the beginning. Okay, the next step is now I recognize that these x's are going to cancel out, so those will cancel, and I'm left with the limit as x approaches 0. In the numerator, since there's nothing left, that means that I need to put a 1. And then in the denominator, I'm going to have the square root of x plus 1 plus 1. Now if I try to plug in 0 again, I'm going to get 1 over the square root of 1 plus 1, which of course is 1 over 2. Okay, so the limit as x approaches 0 of that original function way back up there is equal to 1/2.